Okay, in this video we're going to talk quickly about some reactions of thiols and sulfides. So we mentioned in the previous video that HS- is a strong nucleophile and a weak base. So HS- is going to readily undergo SN2 reactions. And so we can make primary and secondary thiols from SN2 reactions between NaSH and an alkyl halide. So this is really not new reactions. These are reactions that we should already know. If I take an alkyl halide, either primary or secondary, and I react it with NaSH, right, what I'm really reacting it with is the strong nucleophile SH-, and so we can get these SN2 reactions to give me the thiols, right? And in an SN2 reaction, as we would expect, we'll have the inversion of configuration. And of course, I could make sulfides through the same process rather than using NaSH. If I used NaSR, right, I could make a sulfide as opposed to a thiol. Another important reaction of thiols is that they can be converted into disulfides. So I have a disulfide here. It's characterized by a sulfur-sulfur bond. So this is sort of like a peroxide, but instead of an oxygen-oxygen bond, I have a sulfur-sulfur bond. Now I can do this if I react thiols under basic conditions in the presence of Br2. So the first step of this mechanism would be the sodium hydroxide is going to deprotonate the thiol to give me this Rs- ion. Then I have an SN2 step where the S- acts as a nucleophile to form a compound with a bond between sulfur and bromine. Then I get a second SN2 step where I have another S- that acts as a nucleophile, kicks off the bromine as a leaving group, and that forms the disulfide. Now, an important reverse process, the disulfide can be reduced back into the corresponding thiols by reaction with zinc metal. And the reason I mentioned disulfides here is because the bond energy of a sulfur-sulfur bond is relatively small. It's only 53 kilocalories per mole. So this is quite a bit less than a lot of the other covalent bonds that we're going to encounter. And so I don't know that I'm going to ask you specifically so much about the formation of disulfides or the reduction of disulfides to form thiols, but particularly for those of you that are going on to take biochemistry, you're going to find that these disulfide bonds are really important in protein structures. So I at least wanted to mention these reactions so that you've seen these, so they'll be a little bit familiar when you get into biochemistry. And then I think it's important to remember, for those of you that are going on to take biochem, right, that these sulfur-sulfur bonds are relatively weak compared to many other covalent bonds. Now, I mentioned before when we talked about the preparation of thiols that we could also do the same thing to make sulfides, but instead of using NaSH, we would use NaSR. Now, rather than starting directly with NaSR, we might in fact start with a thiol, right? React that with sodium hydroxide, right? And that's going to deprotonate my thiol to give me the NaSR, and then just like we saw on that first slide, we can then have an SN2 reaction that will give me the disulfide. All right, the book talks about two other reactions that sulfides undergo. And I'll be honest, I'm not going to ask you about these reactions specifically. What I would recommend is add these to your reaction journal, and I'll only ask you about these reactions in cases where you would have your reaction journal available to you. The first one the book talks about is SN2 substitution between a sulfide and an alkyl halide. So the sulfide attacks the alkyl halide. The halogen leaves as a leaving group. And when we end up with this product, what's interesting about it is that it's a strong alkylating reagent, right? And so we can use it to add an alkyl group to a variety of nucleophiles. So if I then take this product, I can do another SN2 reaction with some other nucleophile, and thereby adding the original alkyl group to my new nucleophile. All right, the second example of sulfide reactions that the book talks about is that sulfides can be oxidized to sulfoxides, where we have a sulfur double bonded to one oxygen, or sulfones, where we have a sulfur double bonded to two oxygens. And then, depending on how far we want to go in the oxidation, depends on the oxidizing agent that we choose. So, sodium metaperiodate, NaIO4, that will take us to the sulfoxide, where I have the one sulfur oxygen double bond, and hydrogen peroxide takes us all the way to the sulfone, where I end up with two double bond oxygens between sulfur and oxygen.